Hello everyone, good day to all. I welcome all my dear kids to today's online live classes. I'm Pushpashri, faculty of Bhat and Bhat Tutorials, and we handling mathematics for you. So, well, my dear kids, in the last session, we were discussing about the chapter of rational numbers, and there we have learned the rational numbers meaning along with the different properties of rational number. So, there we have learned the properties of rational numbers of closure property, associative property, and also commutative property. Under that, we have studied about the whole numbers as well as integers. And in today's session, let us know how to represent the rational numbers on the number line. So let us start today's session now. So here in today's session, we'll be knowing about the representation of the rational numbers on the number line. So here you can see the natural numbers. So natural numbers are those numbers, the counting numbers which starts with 1 and ends with infinity. Those numbers we are going to call it as rational numbers. And in number line, how to represent that rational number? If we look into that, so you can see the number line over here. So in the number line, on the right side of the numbers, so on the right side of the number line, you can see there is a sign of arrow mark that it is going to state that number is going to continue till infinity. Okay, so here 1, 2, 3, 4, 5, 6, 7, 8, and the arrow that is moving with it is up to infinity. Okay, so here the number starts with 1 and ends with infinity. And here in natural numbers, the line will extend indefinitely only to the right side of 1. So here the line will not exceed. Okay, so the line will not go in on your left hand side, only on your right hand side. So you will get the numbers, all are positive numbers only. So that's the reason we'll tell that the line will gonna extend indefinitely only to the right hand side of the 1. So next one I come to whole numbers. So whole numbers are including natural numbers included along with 0. The numbers along with the natural numbers and along with the 0, we're going to call it that as a whole number. Here also the number starts with 0 and ends with infinity, if you see here, and the line is going to extend indefinitely to the right hand side of 0, and there is no numbers to the left hand side of 0. So you can observe in the line itself. See, on the right side of 0, you have plenty of numbers. Indefinitely it's gonna continue. So how you will get to know it's gonna continue indefinitely? Because of this arrow mark. And the line is going to extend indefinitely from to the right side of 0, but to the left hand side of 0, the line will not continue. So this is about the representation of rational numbers on the number line. So first one is natural number, the second one is whole number. And the next we will see about the integers, how to represent the integers on the number line. If you see here, this is a number line. Here also there is an arrow mark which is on your right hand side. On your left hand side is also there is an arrow mark. What does it means? That means the number will continue indefinitely to the right hand side of 0 and to the left hand side of 0. So then what is integers? So integers are those numbers along with the positive numbers you will get a negative number also. See here 0, on the right hand side of 0 you have all the positive number. If there is no sign before the number means we are going to consider that as a positive number. 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, like that it continues. But when you see to the left hand side of the 0, here you can see -1, -2, -3, -4, and likewise it continues. Okay, so this is what we are going to call it as integers, and the line is going to extend indefinitely on both the sides. And do you see any numbers between -1 and 0 or 0 and 1? So can you see any numbers? No, you can't see any numbers, but there are so many numbers included here. So between 0 to 1, there are infinity of numbers, where the numbers that you can't able to count. Say for example 0.1, 0.001, 0.0001, like that you will get so many numbers. So between 0 and 1, there are infinity numbers, we're gonna tell it as. And then we'll see the fourth one, that is rational numbers. So how to represent the rational numbers on the number line then? So as we have already studied the meaning of rational numbers are those numbers which can be written in the form of p by q, where q will not be equal to 0. So on the right hand side of 0, you can see here the numbers are 1 by 2, 1, like that it will be. So on the left hand side, minus 1 by 2, minus 1, and likewise it continues. That means the line is going to extend indefinitely on both the sides. On the right hand side also it will continue, on the left hand side also the line is going to extend. But you can see now the numbers between 0 and 1, etc. So now you can see the numbers between 0 and 1, whereas in integers only you can see 0 and 1. But when I come to rational numbers, you can see the number between 0 and 1. So here we'll tell, we have one more, the meaning in rational numbers, that where p, it is a p by q, where q is not equal to 0. As you can see here, it's in the form of p by q, and q is not equal to 0. That means the number 2 is not equal to 0. And then, so now we'll just move on to the representation of rational numbers on the number line. They have given the number that is 1 by 8, where we have to represent 1 by 8 on the number line. How to represent that then? See, to represent that 1 by 8 on the number line, we have some of the steps to be followed. We'll see to that. First, we'll draw a number line. So as soon as we draw the number line, we start dividing the number line into 8 equal parts. Usually in the fraction, what happens, if they give you one circle, in that circle if 3 part is shaded, we'll write 3 by 4. That means 3 part has been shaded out of how many parts? That is out of 4 parts. Like that we'll write. In the same way here, 1 by 8 means out of 8 parts you have to represent that 1 by 8 over there. So first you're going to divide the number line into 8 equal parts. You can see 1, 2, 3, 4, 5, 6, 7, and finally it is 8. So to represent 1 by 8 on the number line, we start dividing the number line into 8 equal parts as they have already shown in the figure. So the step 2 is nothing but we use the number 1 by 8 to name the first point in the division, and the second pair of division, that is like 2 by 8, and here it will be 3 by 8, here it will be 4 by 8, 5 by 8, 6 by 8, 7 by 8, and 8 by 8. That is nothing but it is going to be understood that 1 by 8. The same thing, it's continued here. You can see here in the number line. So see 0, 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, and 8 by 8. So 1 by 8. So 1 is there above the line, 8 is there below the line. So 1 is the numerator, 8 is the denominator. And any of the rational number that we can represent on the number line in this way itself. Okay. So in the rational numbers, the number bar below the bar. So that is, the denominator tells the number of equal parts into which the first unit has to be divided. That means 1 by 8. That means here the denominator will tell you that how many parts that we have to divide the number line. Okay. And the number which is there above the bar, that means the number which is there above the line, we are going to call that as a numerator, right? And that numerator will tells you how many of these parts are considered. That means to divide those parts, how much part has to be considered. So out of one part, we have divided the 8 parts likewise. Okay. So the rational numbers such as 1 by 8 means 1 of 8 equal parts on the right side of 0. And then, so what are the points to remember then? So here you can see the first point, rational numbers are closed under operation of addition, subtraction, and multiplication. So as we have already studied about the rational numbers and what are the closed properties of rational numbers. So here rational numbers will be closed under the operation of addition, operation of subtraction, operation of multiplication. So these things that we have already studied in the last session. Remember that table, and that table will represent you how you are going to do it. And the second point here tells you about the operations of addition and multiplications are. So when you're doing the rational numbers, the operation based on the addition and the operation based on the multiplication, what are the ways to treat that, you will get to know. In that, the first point is commutative for rational numbers. We basically use the commutative property, right? And that commutative property for rational numbers, and also you will be learning in this chapter about the associative property of the rational numbers. So commutative property under the four different operations such as addition, subtraction, multiplication and division, as well as the associative property under the four different operation, that is addition, subtraction, multiplication and division. And then the third point, that is the additional rational number, that is nothing but the rational number 0 is an additive identity of the rational numbers, and also the rational number 1 is a multiplicative identity. Always remember, 0 is an additive identity and 1 is a multiplicative identity. And when I come to additive inverse of any of the number or any of the numerical terms here, so if a rational number is there as a by b, so when I come to the additive inverse, we are going to write that vice versa with a negative sign. Okay, that will become a by b will become minus a by b. And when I come to the sixth point, see here the reciprocal and the multiplicative inverse. So we have already studied the reciprocal as well as the multiplicative inverse. And these two, reciprocal and multiplicative inverse of the rational numbers, say for example, like a by b is c by d. And if I'm going to write a by b into c by d, so which will be equal to 1. Okay, because a by b, ab and c by d, cd. So you will get 1. And the seventh point, that is about distributive property. So distributive of the rational numbers, that means how we are going to distribute the numbers. Say for example, a into b plus c is equal to a plus b plus ac, and a into b minus c, which is equal to ab minus ac. How you will get to know it is a distributive property? Then see here, a b plus c is there in inside the bracket. So a into b, that is understood, that is ab. A into c is ac. And the same way, a into b, it is ab. A into c, it is ac. And here there is an operation of subtraction. So that's the reason subtraction is here. Coming to the eighth point, rational numbers can be represented on the number line. Right now we studied that rational numbers can be represented on the number line. And see to the ninth point, between any two given rational numbers, there are countless rational numbers. Say for example, between 0 and 1, there are countless rational numbers. So 1 by 8, right now we have studied, right? 1 by 8, 2 by 8, 3 by 8 and so on. Then we have got it as 1 by 8. So in this 8 by 8, in the same way, here also between 0 and 1, there are infinity of numbers. Either you will get it in fractions or either you will get it in decimals, whatever it might be, but there are countless of rational numbers. And the idea of these will help you to find the rational numbers between the two rational numbers. You can find a different rational number. Okay, so these are the important points that you have to remember when you are working out with a rational number. And this is about your theory part for rational numbers. So in the upcoming session, let us discuss some of the problems based on the rational numbers. And thank you all for attending today's session. So any doubts and queries, you can call to these two numbers, or you can send a message to the app through this Bhat and Bhat Tutorials app. Thank you.